So in this lesson, we're going to come back to an old concept that we just learned, which was arithmetic sequences, and we're going to extend that to arithmetic series. So you're going to want a graphing calculator today because we're going to show you how to use the sum and sequence features as well, and we're going to introduce you to some new formulas. So, learning targets for us today. Let's rediscuss the concept of an arithmetic sequence. So remember, sequences are generally going to be determined by a name of a sub n. So a sub n equals a sub 1 plus, and we usually put the d in front of this, but whatever, d times n minus 1. So that's the arithmetic sequence formula in its most user-friendly form. And then of course we could simplify it when we give a final answer, if that's our job, is to give an explicit formula. But remember, arithmetic sequences have a common difference where you're adding the same number each time. Sometimes that number is negative, so it appears to be subtracting, but same thing. Alright, so this is a review of something we already talked about. But if I could come up with the 38th term, that'd be great. So if you want to figure out the 38th term, you can use your arithmetic formula, which says start with the first term in your sequence, which is -7. And then add your common difference, which you should be able to tell by just looking at the next term. Looks like they're adding 2. And then the general explicit formula is n minus 1, but we just figured out that we're trying to find the 38th term. So we're going to do 38 minus 1. Now, this is not necessarily the only way to get this answer. I already typed this in my calculator, I'm pretty sure. Yeah, this is 67. For a lot of kids, they just think about this conceptually, and they say, all right, well, if I start with a -7, and I need to get to the 38th term, if this is the first term, I need to add 37 steps of 2. So guess what, guys? That's the exact same thing we just did with the formula. So I have no shame in not using the formula explicitly and understanding how the formula works. I do not care how you get these answers, guys. You could technically use your sequence mode on your calculator and go out to the 38th term in your table. It's a little slow, but whatever. So this is a new concept. This is called an arithmetic mean. And arithmetic mean is what we've been calling steps, essentially. So if I tell you that between, what did I say? Between 7 and 47, so right here to right here, there are 3 arithmetic means in between them. To us, we translate that as saying there's 3 steps. So that's a way that we could figure out the arithmetic mean, is to go back and think of them as steps. Let's look at an example here. And I like to list it out just like this. So my first term is 3.2, my last term is 4.4, and there's 1, 2, 3 arithmetic means or steps in between them. So think of it this way, guys. You started with 3.2, and then you added, now this is a little tricky, you gotta be careful here. You're adding 1, 2, 3, and then you actually add 4 steps to get to the 4.4. So 4 steps of whatever that common difference is, and you end up at 4.4. So you have to be careful with this how many steps question, because to get an answer of that last number, you have to add that additional step. So be careful there. We're going to subtract 3.2, and then divide by 4. What was that, 0.3, right? Yeah. So the common difference is 0.3. So write an arithmetic sequence that has 3 arithmetic. Okay, so now they want me to go back and take all the clues I know, where this is the first term and this is my common difference, and actually write the sequence itself. So the sequence formula, explicit formula, would be 3.2 plus the common difference of 0.3 times n minus 1. And then, of course, PreCalc, I expect you to be able to distribute the 0.3 and simplify. So, okay, in my brain, let's see, this is 0.3, but it's -0.3, right? So that would be a 2.9 plus 0.3n. So either one of these formulas for now is okay, and you're going to ask me, what do I want on the test? And frankly, I'm just so tired. I'm just thrilled when you get an answer that's right. Maybe think about simplifying, though. All right, so find the first term of an arithmetic sequence for which a sub 15, so the 15th term is 30, and the common difference is 1.4. Hello. So I need to find the first term. And if you think about this formula, it's the general formula, which means I get to plug in anything that works for me. So this is the explicit using the formula way to do this, all right? So a sub n, the nth term that they're referring to, is the 15th term. So they actually told me what that value was. It is a 30. So the 15th term is 30. I do not know the first term, but I have been told that the common difference is 1.4. And then because 30 is the 15th term, the nth that they're referring to is 15. So in the formula, it's 15 minus 1. So doing a little solving here, 30 equals, I don't know what that comes out to. I didn't write it down. 19.6 maybe? Yeah, that makes sense. Alright. Doing a little math in my head. That's always dangerous, right? So if I subtract 19.6, I get my first term to be 10.4. So that is a great way to find the first term. However, this is how I originally keyed it, because I'm like old school and I don't like formulas, because back in my day, no one gave me any formulas, so I had to really think about what the formula meant. That's not really true. A lot of teachers gave me formulas, but I did have one particular teacher who would not give me any formulas, so I learned to cope, right? And I think of it this way. If I need to get back to the first term, and then out here I have the 15th term, and I think about how am I going to back up to the first term, I'm going to back up 14 steps to figure out what this term is. So what I did was I said, okay, start with your 30, and then back up 14 steps, which are 1.4. That was the common difference, right? And guess what answer I get? I get 10.4. So I don't care if you follow the formula or you want to use your conceptual brain and figure out what's really going on in the sequence, whatever you are more efficient at. For a lot of kids, the formula is more efficient just because it's May and they're not really excited about thinking anymore. Alright, so find the common difference in the arithmetic sequence for which a sub 1, so the first term is 6, and then the random 40th term out there is 142.5. So, again, you're welcome to use the formula. Now, instead of just an nth term, they're giving me the 40th term. So the 40th term is 142.5. The first term is 6. I have no idea what the common difference is. But if I use the 40th term, that's the n that I plug in right here, right? So it's 40, but minus 1. Alright. So solving for this guy, let's see, that's 142.5 equals 6 plus 3090. And we're going to subtract. Alright, so we're subtracting 6. Oh boy, let's see. 136.5, I think. I don't know. I already solved this, so if I got a little mistake there, I apologize. If I divide by 39 here, what'd I get? Number 2, huh? I got 3.5. Now, the reason I don't have all this work written down, because that's not actually the way I did the question. So the way I did the question was I said, all right, start with the first term of 6, and then you added, so to get to the 40th term, I added 39 steps of some mystery value, and I got to 142.5. And when I solved this equation, I got 3.5. So they're essentially the same arithmetic. It's just, are you explicitly using the formula, or are you just conceptualizing what the sequence looks like? But they're actually the same math. This is one of those moments in math where sometimes your math teacher tells you, like, no, you have to use the formula. Well, you are using the formula when you do it with the conceptual approach, so I don't mind. Okay, first term, the nth term, common difference, and we're supposed to find what the nth is. So 27 is some mystery term, and I started with negative 12, and then you're adding 3 for a common difference each time. But remember, I don't know n, so this is going to stay a variable. All right, let's solve this. We're going to add the 12. So 39 equals 3 times n minus 1. So when I divide by 3 on both sides, I get 13 equals n minus 1. Whoopsies. And then n equals 14. So it looks like the 27 was in reference to the 14th term of our sequence. Alright, what else do we have here? Oh, partial sums are coming up next. Okay, so here's another arithmetic sequence with arithmetic means. Okay, so it has 3 arithmetic means, which we know means steps, right? Blanks, if you want to call them that. Between 17 and 39. But you got to be a little careful, because remember, we have to actually get to 39. So while there are 3 missing steps, there's actually 4 additions that happened here. Because to go from 17 to here is 1 step, 2 step, 3 step, and then they actually did 4 steps to get to the 39. So 17 plus 4 mystery steps is 39. If we solve that, let's see here. Really testing my arithmetic today, guys. All right, 22. D is, should be able to do that, right? So that arithmetic mean is 2.25? No, that doesn't make sense. Did I screw this up? No, I'm looking at the wrong question. All right, it's, 5.5. That makes sense. All right, and then it does say write an arithmetic sequence. So we're going to go back. The first term of the sequence was 17. Just found out our common difference was 5.5 times n minus 1. Let's leave it in that form. All right, trucking along here. Write a sequence that has 7 arithmetic means between -2 and 16. So 7 blanks, but remember that's 8 hops or steps to get to 16. So adding 2 over, we got 8d equals 18, and d equals 2.25, right? There we go. So then they want the arithmetic sequence, and again, whatever form at this point, guys. First term is -2. Common difference is 2.25. Now, it does say write the sequence. I'm kind of assuming that -2 is the first term, because that's the first one they gave me. But if that's just a part of the sequence, then this isn't actually the right answer, so whatever. Sorry about that. Okay, these formulas. They're both cool. This is my favorite one by far. They're actually related to each other, because how you find this nth term is using the formula. So I actually think this formula is the best one to use when using a summation formula. So remember, S sub n means it's a series, or you're summing all the terms. So it's like the first term plus the second term plus all the way out to whatever the nth term is. So it has to be a finite series for us to use this formula, meaning it ends. So I want to find the sum of the first 50 terms. So there's your n. And this was really nice. They went ahead and gave me the first and last term. So look how easy this formula is going to be. The 50th, it's not really a partial sum, it's the sum of the first 50 terms. So 50 over 2, I'm using this formula here, and then times the first term plus the last term. I think this is referred to as the triangular sum or something like that, somewhere else in math. So when I get that typed in the calculator, wrong page, it's 4,225 is the sum of the first 50 terms. So get used to this notation. S means to sum them. 23rd term's not known in this problem. So if you're going to use that formula, you got to find the 23rd term. So switch back to sequence for a moment, and let's find the 23rd term. So it's arithmetic, because I can see that there's an arithmetic pattern here. Looks like they're subtracting 11 each time. D. So the first term is 173. And then they add a -11 or subtract 11, and then n minus 1 times. So that'd be 23 minus 1, or 22 you could put there. So calculating this number, the 23rd term is -69. So I know the first term, and now I know the last term of this series, and I can use my formula. So the sum of the 23 terms is, where are we at? 23 over 2, and then first term plus the last term, plus -69 is kind of weird, but whatever. And when I calculate that, I got the sum being 1,196. Now, I'm going to show you a method that you could use as an alternate way of solving this, okay? So on your calculator, remember that sum sequence business? I really like using sum sequence. I don't know why. Your calculator is very adaptive, and as long as you put a formula in that works, that's appropriate, it'll take whatever form it's in. You don't have to simplify it or anything. So I'm going to go to second list and go to math. And then after you do a few of these in a row, you just learn it's math 5 followed by ops 5. So math 5, and then while in there, go back to the list menu, and this time go to ops 5. So we're going to be summing a sequence. So now it's going to, on this newer model, it's going to ask me, okay, what's your explicit formula? Any form. So remember 173 was the first term, and then you can say plus -11. I'm just going to say minus 11, and then times n minus 1. I'm not in sequence mode, so it's using x, but whatever. The variable I'm using is x, and then it was starting at the first term and going to the 23rd term. Now, is this quicker? I don't know. I don't really care because it's going to paste it into the formula. Remember, if you're using your older models, you have to type those in separately, so that is kind of a pain in the tushy. So if you have an older calculator, maybe don't use this method, but we're going to get the same summation of that series, so, or summation of the sequence, I should say. It's up to you. So write yourself a little note. You can still do sum of the sequence on your calculator. I don't know why, I just really like doing it that way. So you'll see a lot of my answer keys don't have any work because I just summed the sequence on my calculator. So, first term is -1. I can tell that we're subtracting 3 each time. So there's a common difference. I want you to find the sum of the 82nd term. Oh boy, up to the 82nd term. So we need to find the 82nd term if we're going to use that formula. So first term plus the common difference, so -3 times n minus 1. So the 82nd term is, I think I calculated that. Let's find out. -244. So now I'm going to go find the summation, or the series, of the 82 terms using this new formula. So 82 terms divided by 2. First term is -1, plus last term is -244. So on my calculator, of course, because I'm not doing that in my head, that is -10,045. So once again, totally could have done sum of the sequence in your calculator. If you have a newer model calculator, it's going to paste everything in for you. If you have an older one, you have to go back and remember the order of what you type in. So the order is the formula, comma x, comma first term, comma last term. Starting and ending number, I should say. So like on this question, it would have been start at 1, end at 82. So it's not the end of the world if you don't have a newer calculator, guys. The old one works just fine. It's just, man, that upgrade of pasting into the formula is one of my favorite things about the new operating system. Alright, so I'll find the sum of the first 25 terms. Oh, this is beautiful. They already told me the first and last. How wonderful. So I am going to use this formula. So 25 over 2, 7 plus 79. Easy peasy, lemon squeezy. Yes, 1075. That would be a wonderful set of homework questions if they're all that easy, huh? But they're not going to be. They're going to be more like this, where you need to find the 53rd term. Don't know what that is. So let's figure it out. So the 53rd term of the sequence first is 12 plus, let's see, they're adding 8 here each time, right? And then 53rd term, but -1 because you already started with the first term. So this on my calculator tells me that the 53rd term is 428. So now going back and finding the sum of my 53 terms. First term was 12, just found out our last term was 428. On my calculator I get 11,660. So again, sum of the sequence works great on your calculator as well. This one I am for sure using sum of the sequence because they explicitly give me the formula, so they're just like begging for you to do this. Now this happens to be arithmetic, but you would know that if you found the first couple terms you could see the arithmetic sequence. But I'm just going to use my calculator, guys. This one is a beautiful use of your calculator. So sum of the sequence again. So real quick it goes list math 5, list ops 5. So list math 5, and then while you're in there, list ops 5. That's convenient, right? Alright, so your formula is changing. Whoops, hit clear. And it was now a 3n plus 1. 3x plus 1 in my mode. I'm using x as my variable, and they want me to go from, okay, this is weird because it's starting at the 3rd term going to the 15th. So 3 to 15. And then we're going to paste. Don't worry about the steps. It'll always count by 1s as a default. There we go. 364? Yeah, that's my answer. And then this one it says, nope, now you got to use the formula. Okay. You should be able to be flexible in math, right? Because what if you don't have a calculator and you got to do this old school? So formula is 2n, and I want the 42nd terms, because the first term is easy. I just plug in a 1, and I get 2. But the 42nd term, I got to plug in a 42. So let's see, that's 84, right? So using my formula, oh, this really isn't bad at all. The sum of our 42 terms would be 42 over 2, and then 2 plus 84 in the parentheses. So I get 1,806 as the sum, get used to the notation, of the 42 terms. All right, we're going to keep on going. We got a couple more. We are designing an auditorium, and it has 26 rows. The first row has 22 seats, so that's a sub 1, the first term. And then every row after that, it increases by 4. It has a shape of an auditorium where it fans out. So the increase by 4 part, that's the common difference, D. So let's go ahead and jot down a formula. Starts with 22 seats, and then it increases by 4 every row after that. How many seats are in the last row? Well, there's 26 rows, right? So you need to find the 26th term, which I would just, you already have it, so let's just use our formula. 22 plus 4 times 26 minus 1. So when I can't do mental math, so when I type that in, I get 122 seats. That's how many seats are just in that last row, the back row of the auditorium. But now they want the seating capacity. So basically you have to add up how many are in each of your rows. Well, we have that. We have the last seat and we have the first seat. So let's just do that, guys. The sum of the 26 rows would be 26 over 2. And then we started with 22 seats, but the final row has 122 seats. So on my calculator, 1,872 seats. So that's kind of a neat application. It's a simple application, but that is the type of thing that we would see for an application of a sequence, or a series actually. So the first year's salary of an employee, oh, this is another good application, starts off with $34,500. And then you're going to get this weird flat increase at $750. So that's the common difference. This is a linear growth, which isn't typical for most jobs, but I will tell you, on a teaching contract, there is a bit of a linear growth component. So what's her salary going to be in the 10th year of work? Well, I guess we'll find that. So the 10th term. So 34,500 is her starting point, and then she's adding 750 every year, but this is 10 years. But remember, guys, subtract 1 because this is her first year. So on my calculator, that comes out to 41,250. And then be careful on this question. It says, how much will she earn in total after 25 years of work? So they want you to sum up 25 years of work. So don't use this number because that's 10 years of work. You have to go back and find 25 years of work. So I already did this. That's not 25. But that is dyslexia. All right, A sub 25, the 25th year. Oh, you know what? I didn't write that down. You know why? Because I cheated. I used sum of the sequence on my calculator. So I did sum sequence, and then I pasted everything in, but what I typed in technically would have been 34,500 plus 750 x minus 1, comma, x, whoops, comma, and then from year 1 to year 25. And then that, in my calculator, produced $1,087,500. That's a fun thought. Just making $1 million over 25 years, but whatever. Decent. All right, and that's your book assignment for the lesson. We have just one more lesson in this unit. It's going to be a similar lesson, but we're going to talk about geometric sequences and series after this.